Hi viewers, you are welcome to Catch Up Math channel. So in this tutorial, I will be teaching you how to solve questions on the maclaurin series. So when you look on the board, don't be nervous about all these maclaurin series. They are actually very simple. So this is the for f of x to be exponential x. This is the maclaurin series for that. So these functions you have in the left hand side, these are their maclaurin series. Now, how do you obtain this? Is very simple. That's what you are going to do in this tutorial. Now, the first thing you have to understand is to know the formula of maclaurin series. Now, here this is the formula of maclaurin series, which is given to be n is equal to 0 to infinity xn f of 0 divided by n factorial. So now, I'll be teaching you one simple method that will enable you, that will make you to solve, that will help you to solve this question without any stress. So now let's look at the method. So you have to have n, then of x, then of 0. So in this place, you don't have to stress yourself. So the only thing you need to do is just to find this, the second and third column. The second and third column. So you don't have to, you already given the first column before. That is the value for n. When you look at the formula for maclaurin series, it's given to be n from 0 towards infinity. So that means the value for n starts from 0. So from this letter zone, we are going to add the value for n to be 0, 1, 2, 3, and 4. Okay, let's stop at n is equals to 4. That's at fifth term. So using this value for n to obtain this. Now the first thing you have here is that at n is equals to 0, when you put 0 there, you are going to have 0x. So this same thing as f of x. So and you already know f of x. The first thing, don't forget, the first thing we want to solve is to check for f of x to be this. That's the first thing we want to solve. F of x is equals to exponential x. So after solving this, this is what we must obtain. Okay, if f of x is exponential x, that means this is what you are going to have on this side. Okay, at n is equals to 1, you have f prime of x. So f prime of x is what? That means you just have to differentiate exponential x. Don't forget, when you differentiate exponential x, you're still going to have exponential x. So in this place, you still have exponential x. So at n is 2. By the time you put 2 there, you have f prime prime of x. When you differentiate this again, you have exponential x. So you have e of x. Okay, at n is 3. So to obtain this, you need to differentiate this again. You are going to have exponential x. So this is exponential x, and the last one will still remain as exponential x. You can see it's actually simple. Now, okay, to get the last column here, you don't have to stress yourself. Don't forget that maclaurin series is a special case of Taylor series, center at 0. That is when the value for x naught is equal to 0. That is what maclaurin series. Are you with me? Okay, fine. To get the last column here, you don't need to stress yourself. Anywhere you see x in the second column, just make the substitution to be 0. Okay, by the time you put 0 here, you have what? 1. X is equal to 0, you have 1, you have 1, you have 1, then you have 1. Okay, that's what you obtain. Okay, from this formula, we already obtained this. So what else do we need to find? Xn. Okay, you have f of x to be summation n is equals to 0 to infinity, then x raised to the power of n of 0 divided by n factorial. So what is the common thing in this place? You notice that everything here is equals to 1. Do you get it now? So which implies that your f of 0 here is what? 1. Okay, if that's the case, from this, you just make the substitution for f of 0 in this place, which is summation n is equals to 0 to infinity. Then s raised to the power of n multiplied by 1 divided by n factorial. So s raised to the power n multiplied by 1. So that will be still remain as this. That will be summation n is equals to 0 to infinity. Then s raised to the power of n divided by n factorial. And this is the maclaurin series of exponential x. So which happens to be this. So by the time we make substitution for the value for n, we are going to get this one. So now that's the very simple method to use to solve exponential x. Okay.